Okay, so the second video that we're going to do is a little bit different. This video is going to focus on some applications of the idea of expectation. And in this video, I'm really going to show you how this is used. I'm not expecting you to kind of apply this for yourself, but I do want you to kind of get a feel for why we study expectation. Um, so I'm going to talk you through the information that's here. And this relates to insurance. So if you take out insurance, that is a way of, so you might insure your phone, which means if you break it, the insurance company might pay some of the money back that it would cost to get a new phone. And you can insure most things. Most people's cars are insured, houses are insured. Lots of people now insure their phone. Anything that's really valuable, people are likely to insure. But you might think, well, okay, if I break my phone, my insurance company is going to pay out most of the cost of repairing it, but I only have to pay them £2 or £3 a month to insure that. And that seems very odd. So for example, my house insurance is £100 a year, and yet if my house burns down, it would cost hundreds of thousands of pounds to rebuild it. How on earth can insurance make money? Well, here is a bit of how insurance works. So the first thing the insurance company will do will look at the chances, the probability of different situations. So the probability maybe of a small payout. So let's talk about houses. What's the probability that a tree falls on the roof and they have to pay for a bit of kind of work on the roof, or a big storm blows some slates off and I have to claim on the insurance? That's going to be a very small payout, maybe £1,000 payout. So they'll assess all of the risks of that. So maybe they put together all their risks, all the probabilities that they know about, whether it's slates blowing off or a bit of water damage or some small incident. They'll put all their probabilities together and they'll figure out that actually there's a 1 in 150 chance, so 1 out of 150 chance of paying out that amount of money, which was £1,000. Maybe a bigger incident, maybe here, some major damage like that tree falling and breaking the roof, or a small fire breaking out, or flooding. And so they put together all their chances and get 1 in 400, and the payout is £10,000. Or there's a huge payout, and so like some major damage happens to the house, the whole house is flooded, um, or a whole house affected by some earthquake or storm. Not an earthquake in the UK, but in other places in the world, these are the kind of risks they're taking into account, and they work out there's a 1 in 8,000 chance of that happening, and that on average the payout for that is £100,000. They will do this in a lot of detail to work out how much they expect to pay out. They will take a probability of a small payout and times it by the small payout amount of money that they on average will pay out. So we'll do 150 times 1,000 plus 1 in 400 times 10,000 plus 1 in 8,000 times 100,000. And they will work out that value of the insurance policy. Now, in this particular case, I've actually worked all of this out in advance, and you get 44.17. I'm rounding up 2 decimal places. So you would expect, or the insurance company would expect, given all of these risks and all of these payouts, on average, a customer will need to get paid £44.17. Now, it's important to pick out, very few customers will ever get paid £44.17. That's your average payout, so like your mean payout. So some people will get paid £100,000. Some people will claim nothing. Some people will claim 20 or £30,000 in a big payout. But on average, given the probabilities of these different events and given the value of the different payouts, we'd expect the average customer to be £44.17. Now they've actually already charged us for our insurance policy £150. So we get £150, take away 44.17, and that leaves us with £105.83. So that is the amount of profit that the insurance company makes. This is what they expect to pay out, and assuming that everything works to the probabilities that they've calculated, that's what they'll end up paying out if you take a lot of customers and average them all out. So anything that's left out of our insurance payment is profit for the company. So when insurance companies work, they spend a lot of effort working out these probabilities, and it's why maybe if you're insuring a car and you're a young driver, you'll pay a lot more, because insurance companies will actually realize that the probability of a small or a big payout is much higher. They'll look at all the people driving in the country and all the accidents, and they will work out that the probability of a young driver having an accident is much higher, which is why your paying will be bigger, because they'll work out their expected value. So it gives you a bit of an example of where probability is used. The second one maybe is a more one you're more aware of, and that is if you're kind of gambling and you're looking at, say, slot machines or something. They will do exactly the same type of calculations, and in fact, I'll give you a quick example. So for the first line here, the probability of the winning combination is the cherry and then anything. So the probability of getting a cherry is 9 cherries out of 82. So you've got a 9 out of 82 chance of ending up with this category here. If you do win, you win £4. But you've paid in £1. We'll come back to that in a minute. So you're doing 9 over 82 times 4, and you want to know what that gives you. Working in decimals, that gives you 0.439. So if that was the only option on your £1 that you pay in, you'd expect to get about 44 pence back. And so that's your expected winnings in this case, is 44 pence on your pound that you pay in. Now we can't leave it at that, because actually there are other options here. Now, working out how likely these different options here is a little bit tricky, and actually something that we're not going to go into at the moment. But we can work out all of these probabilities, and I'm just going to quickly pause this video, write down all the probabilities so you can see them, and then we can work out our expectations. Okay, so looking at our probabilities, I've written them down here now, so I've just quickly written them down. You can do a little bit of research for yourself and find out how these come from. The chance of getting a bar here is 19 out of 82. On reel 2, it's 27 out of 82, 25 out of 82 on reel 3. Multiplying those probabilities together, that's something again, it goes a bit beyond where we're at. Multiplying together gives us the probability of getting bar on all 3 of them at the same time. So I've worked all those out. We need to now times our payout by our probability, and that will give us our expected winnings. So 10 times that gives me 0.23. 25 times that gives me 0.13. 50 times that number there, 0.076. I'm keeping a little bit more detail in money at the moment because I don't want to overround too early. And that one, 0.00725. If I add all of these up, I get 0.89675. I'm going to round that to the nearest whole penny. So approximately 90 pence. So by taking my payout times the probability of winning, I get my expected winnings from each outcome. I can add all of those expected winnings up, and that means I expect to get 90 pence every time I play. But hang on a second, I paid £1 to play. So just because I expect to win 90 pence isn't good, because I paid £1 to play, and so I'm actually losing. I expect to lose on average 10 pence every time I play. Now you will have some wins. Almost certainly, if you play this lots of times, like a few thousand times, you will expect to have a good number of wins. You will even sometimes, if you play 1,000 times, you expect to win the jackpot 7 times. But you also expect to have lots of plays where you never win anything. And actually, if you combine all of those together, on average, for your £1 that you're paying in, you're only going to win 90 pence of it back. And actually, every single slot machine you can ever find is carefully calculated like this, so that your expected winnings are always less than the amount of money you're paying to play. So, it sounds rubbish, but actually these machines are made so that you lose money. If you play enough times and you keep playing, you will lose money on any kind of gambling machine which is electronic, because they're actually calculated. If you look really carefully, although people might get suspicious if you're doing this, but somewhere on that machine there will be a little plate that will say it's got a 90% payback. So you'll make back 90% of the money that you pay in the first place. So here we're getting 90 pence out of every £1 or 100 pence that we pay in. And actually every single one of these machines has to state its payback. Now, last little thing I'm going to say, I know it's quite a long video, but last little thing I would say on this. Sometimes you will win the jackpot and you'll leave a bit rich, £1,000 richer than you went in. That doesn't mean that the probability is broken. It just means that someone else has already, all the plays that happen on this machine will pay back at that average 90 pence. So you might be the lucky winner, but most of the time people will be losing money on one of these machines. So hopefully that gives you a sense of where this expectation kind of can go, and some of the more complicated calculations it can do. There aren't any questions to kind of follow up on this, but hopefully it gives you a little bit of stuff to think about. Go and read a little bit more about it. You could even look at maybe say your expected winnings in a couple of other situations, or go and search a little video about explaining about risks and insurance. Lots of interesting things to go and read and take in on this topic. Hope that was interesting, and have a go. Make sure you've done all the expectation questions and the other tasks for this week.